Okay, as promised, another screencast now on binomial distribution. So this is a probability distribution where there are two possibilities, because binomial means two, doesn't it? That says possibilities, so that's not very clever. Possibilities, right. So two possibilities, typically a hit-miss, pass-fail, that sort of stuff. So I'm going to bring in an example, a distribution where there's just have a look at this. There's just some subtle differences to what we were just looking at. We were just looking at a random probability distribution where we were letting a random variable represent a number of heads or the number of the sum of two dice, so it just represented a whole number and it could have been anything. Here we're looking at there are two possible outcomes in an event, and we're going to repeat that event over and over and over, and we're going to see how many, what it's likely to end up with. So for example, let's say the probability of hitting a target, and that target could be a basket in basketball. Yeah, that's it. It could be a target in archery. It could be, throwing a piece of paper at a bin. The probability of hitting a target is, let's say, 0.4. All right, so find the probabilities of probabilities with, maybe I'll just start with 6 shots. Right, so what this is saying really is, let's take 6 shots and let's find the probabilities of making 0 hits, 1 hit, 2 hits, 3 hits, 4 hits, 5 hits, 6 hits. So it's a little bit like what we were doing, but now we're going to say number of hits. So that's like our random variable. So number of hits, 0, 1, 2. Right, so we could have represented, this could be a probability distribution, but we're going to deviate from that slightly. Now, the number of, right, so what's the probability that we'll make no hits? So 0 successes. 0.4 is success, so 0.6 is a miss. We're going to miss all 6 times. That's pretty sad, but that's 0.6 to the power of 6, isn't it? That's missing every single one. Okay, what's the probability of hitting all of them? Let's go up here. Hitting all of them, 6 shots out of 6. That's 0.4 to the power of 6, isn't it? Right, so what about the probability of 1 hit? So if I hit once, I'm missing 5 times. So in here, I'm going to need more space than this. I'm hitting once, right? And I'm missing 5 times. So that's 0.4 by 0.6 to the power of 5. Because if you think of these 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Right, then what we're doing is we're doing a hit and then a whole bunch of misses. And the idea there is that this is 0.4 probability and these are 0.6 probabilities, and we multiply the probabilities together, don't we? Right, but that hit could occur anywhere along there, couldn't it? So it's 6 times that. Now that 6 we're going to write in a different way. We're going to write it in Ncr notation. So that 6 from this point onwards is going to be known as 6C1, which I'm going to write like that. 6, that means 6C1, which is the same as 6. Righto, so in here, that's going to be 6C2 times, because there's 6C2 numbers of ways of having 2 hits, 0.4 squared, times 0.6 to the power of 4. That's going to go in there. That number is going to go in there. This is our probability distribution. It's massive. Okay, we put all these together. The 4, what would that be? That would be 6, 4. 0.4, we get 4 hits and 2 misses. You see what we're doing here? In the 5 spot, 6, 5. We've got 5 hits now. 0.4 probability of a hit, 0.6 probability of a miss, just 1 miss. And I don't want to leave 3 out. Let's fit him in there somewhere. That would be, you guessed it, 6, 3, 0.4 to the power of 3, 0.6 to the power of 3. Right, so in there go all those probabilities. It's going to take ages to fill out all those, but if we did, we'd add them all up, we would get a sum of 1, and that's what would work there. Now, our calculators are great at doing this sort of thing. We can put in, I'll show you on here, there's this thing called a binomial distribution. So in menu, probability, distributions, way down at Binomial Pdf. Right, this number of trials. So the number of trials here was 6. The probability of success was 0.4. Remember, we defined it as. Now, x value optional. Right, so if I wanted to find a specific value, I'd put that in there, and it would give the answer for me. So if I just put in here, what should I put in there? 3. So the probability of 3 successes out of 6, when the probability of success is 0.4. I hit OK. And I get 0.27648. That's for 3. 0.27648. Let's reduce that. That was equal to 0.27648. I think that was it. 27648. Yes, it was. Right, that goes into that slot there. Right. So that's brilliant. But what's even more useful, perhaps, if we can go back in and do all that again. So remember, it was in menu, probability, distributions, way down here too. Well, cancel that. Menu, probability, distributions, down to binomial PDF. Number of trials, 6. 6 shots at the basket, remember, 0.4 probability of success. I'm now not going to fill that in. What it will do, it will give me all of them. Look at that, 0.047. If I wanted to round it, that's in here, 0.047. That's 0.6 to the power of 6, and you could find that out by putting that into your calculator just to make sure. 0.6 to the power of 6 is to make sure this thing's doing the right thing. 0.6 to the power of 6. Hit enter. Look at that, it's the same number. Love it. 0.187 goes in the next slot. 0.187. Okay, we resume the screencast. I just got interrupted there to go to the Founders Day dinner. Okay, so we've got our probabilities here for just recapping the probability of hitting a target with 6 shots and the number of successes down here, and we've worked out how to calculate those. Right, I want to go to, say, just another example where perhaps now we take the same probability, same scenario, still shooting at a target. Let's now take 10 shots at a target and see what gives there. So we're taking so the probability of hitting a target is, let's just change it up a bit. We'll take it to 0.3. Probability of hitting a target is 0.3. 10 shots, 10 attempts are taken at the target. Right, now that's the scenario. We're taking 10 shots at the target and the probability of success is 0.3. So I'm going to ask a few questions on the back of this. A, what is the probability of hitting the target, let's say 5 times. 5 times, exactly 5 times. Okay, so what we would do there is we would go into our calculators. Actually, we'll do it manually as well. So I'll just flip this down. 5 times. So what we've worked out there is we're going to have 10 shots at the target, and we're going to miss 5 times, and we're going to hit 5 times. So it's going to be 0.3 to the power of 5 times 0.7 to the power of 5. That's 5 hits at 0.3, 5 misses at 0.7. But we've also worked out, haven't we, that there are 10C5 different combinations of 5 hits and 5 misses. So for instance, hit, miss, 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 miss. That's one. Then there's hit, hit, miss, miss, hit, hit, miss, miss, hit, miss. So there's 10 C5 lots of those. That stacks. This would be, we could run that through and we would get the solution. We might even do that. 10, 5, so don't know what that's doing. Go away. Extraordinary behavior. 10 C5. So we'll go in here and I'll do, going through, this will take us, not statistics, sorry, probability, combinations. We're going for 10, comma 5 times, what was it, 0.3 to the power of 5 times 0.7 to the power of 5, and you hit enter and we get 0.103 to 3 decimal places. 0.103. 0.103, which is about a 10% chance of hitting the target exactly 5 times. Now, using the calculator for that, we go into, remember, menu, probability, distributions, all the way down to, see if you hit the wrong thing, you're in trouble. Probability, distributions, down we go, Binomial Pdf. That guy there, Binomial Pdf. So the number of trials in this case is 10. The number of probability of success is 0.3. Now the value, the x value, is the number of successes. So we're examining 5 successes. We click OK. Click OK. Get 0.103. So that you can see there that those two operations get us the same result. So that's great. That's useful. Now let's answer another question. B, what is the probability? What is the probability? And this is perhaps a more interesting question because exactly 5, I mean, really, are we that interested in exactly 5? Maybe we're interested in at least 5. So we're going to hit the target at least 5 times. So 5, 6, 7, 8, 9, or 10, which would be a great result given that there's only a 0.3 probability of hitting the target. By the way, 0.3, if 0.3 is our probability and we have 10 shots, we would expect to get the target 3 times. So 3 times would be our greatest probability if we calculated the probability of 3 hits. What is the probability of at least 5 hits? 5 hits in 10. So, well, that's going to be 10. That's going to be this. It's going to be 10, 6, 0.3 to the 6, 0.7 to the 3. It's plus 10, 7. So it'll be, right, we could start looking at that. So we'd be working out the probability of 5 hits. And then we'd be working out the probability plus the probability of 6 hits. Okay, you can see what's going on here. 0.7 to the 4 plus the probability of 7 hits. Okay, 0.3 to the 7, 0.7 to the 3, and you can see, all right, this is going to go all the way up to 10 hits, which is 0.3 to the power of 10. We can do all that. That's quite a long calculation, or we can just go in here and we can access this. Right, distributions now. We're not going to choose PDF. Binomial CDF. Look at this. Number of trials 10. Probability of success, all still the same there, 0.3, but now our lower bound is 5 and our upper bound is 10. So we're now saying, give me that sum. Tell me what it is. From 5 to 10, it's 0.150. 0.150. 0.150. So there's only 15% chance of at least 5 hits. So that's how to do those sorts of questions. Perhaps what is the probability of at most 3 hits would be an interesting one, because we decided that 3 was our most likely. What is the probability of at most 3 hits? So that would be 0 plus 1 plus 2 plus 3. we can go in here and calculate using, again, probability, distributions, down to binomial CDF, number of trials 10, probability of success 0.3, lower bound 5, upper bound 3. Okay, calculate that for me. Look at that, 0.649 or 0.650 to 3 decimal places. 0.650, that's equal to 0.650, so 65% of it, most 3 hits. And that sort of makes sense given that there's only a 0.3 probability of success. So that's how to use what's called the binomial distribution to calculate probabilities where there are 2 options, hit or miss, pass or fail. So hopefully now with that up your sleeve, you can have a go at the work requirements on 13C. That is your holiday homework. Have a great couple of weeks. I'll see you back in July.